Oh, awesome. First, I'd like to apologize. I have a bit of a cough today, so I might be making some loud sounds over the course of the next 30 minutes or so. Welcome to my talk on the future of machine learning and JavaScript. My name is Asim Hussain. You can find me on Twitter as Jawake. Not Joashe, Jawake. And I'm Jawake everywhere. I'm Jawake on YouTube, I'm Jawake on GitHub, I'm Jawake on Gmail, I'm Jawake everywhere. That's the advantage of having a weird handle, is you always get it. And I blog about mainly JavaScript-related things on my website. Well, asim.dev and codecraft.tv. I got the dev. Got it? Own it. And I'm also a cloud advocate at Microsoft. In fact, I lead advocacy for EMEA. We are essentially the open source advocates. We work at Microsoft. Each of us has specialities in different kind of open source technologies and frameworks and languages. We're a fairly small, unique team. And you can find, if you go to that link there, you'll find all of us, whatever specialty you have. That we've got somebody there, and we're all available online, and we work in the Azure cloud platform. And if you want to meet with anybody or speak with anybody or find out stuff about the product teams, what's going on there, then you can contact us. Anybody here heard of Udemy? Udemy? Anybody here my students on Udemy? Come on. Not even one. Damn it. Okay, so on Udemy, I'm an instructor on Udemy. And about a year and a half ago, they added in automatic subtitling, and they correctly transcribed my name to awesome. So my name is Awesome. Okay, it's another way of pronouncing my name. This is the correct one. My name is Awesome, and hopefully this talk will be awesome as well. So so who here has actually, would you say, who here has actually a background in machine learning? Okay, now you're going to find this talk quite dull. This talk is probably more for people who are JavaScript developers who are kind of trying to get introduced into machine learning. But maybe there'll be some parts of this which you find hopefully relevant. That's kind of my get out of jail free card for the really tough questions. That's what this is about. So a year and a half ago, or start of last year, a friend of mine, Elna Haproff, we were going for a walk on a hill. It was very painful. And then we stopped in a pub to have a drink. That was much better. And then we started talking. At the time, there were kind of various technologies, various kind of machine learning areas that were just starting to appear in the JavaScript world. Prior to like 2017, 16, there was not really much in the machine learning space with JavaScript. But started last year, things started happening. We said, why don't we create a meetup group? And we started talking about it, and we did. We created a meetup group in London called AI JavaScript. It's quite successful now. It's actually one of the. I'm very proud. It's one of the fastest growing meetup groups in London. And we started running like very regular events. Excuse me. Very regular events, talking about anything to do with AI and JavaScript, kind of that big, broad area. And what would happen is at the end of our each session, sometimes somebody would come up to us and go, "Oh, Asim L, have you heard about this application? Have you seen this thing? Have you found about this thing that someone released online?" Well, no, but that's an amazing little thing that someone's built. Like, I wish there was a website which captured all of those, and kind of talked a little bit about each of those things. And that's then what we created was a website called AI-JS Rocks. If you go to AI-JS Rocks, what you'll find is a whole list of JavaScript applications which have some sort of AI component to them, whatever that looks like. And this JavaScript, which means that typically you can kind of view source and you can see how it was built. All of them have got, at the very least, have a link to source code. They're all open source things. So if you wanted to see how, if you see something, you get inspired. It's all JavaScript, so it works in the browser. So you get inspired, and then you want to say, well, how does it actually work? You can click in, look at the code on GitHub, and kind of figure out how things work. And that's been kind of my journey into the machine learning space, has been, wow, that's a cool demo. How does that work? and then digging in and digging in, digging in. I have the really big advantage is that I just basically would call up all the creators and do interviews, and then I learned about things that way. And so what we're going to do today in this talk is we're going to go over 3 applications that are on AI.js Rocks. We're going to show you how they work, and then we're going to dig into each one, and we're going to go a little bit deeper and a little bit deeper, a little bit deeper into machine learning, and at the end we're going to go quite deep into some topics, and we're going to bring it back to JavaScript each and every time, and through each application you'll learn a little bit more, and then you'll learn a little bit more, then you'll learn a little bit more. And that's what we're going to go through today in this lecture. Lecture? It's a lecture, I like it. So the first one is one I made. It's called the Emojifier. It's not trademarked. It's just the Emojifier, so I thought it'd be a good little punctuation point at the end. Does something amazing, spectacular, if I may be so bold. If you give it an image with some faces inside, it will detect the faces. It will then detect the emotion in the face, and any guesses? It will emojify it. That's exactly right. It will calculate the correct emoji for that emotion, replace it over the image, and that's what the Emojifier does. As I said, spectacular, world-altering, life-changing. I am accepting offers of investment if there's anything on the table here. It has many different forms. The latest form is actually as a Slack bot. So in fact, if you go to themojifier.com and you just click that Add to Slack button, and you have a Slack instance at work, it will literally add the Emojifier to your work Slack instance. And how it works is this. So basically, you just type, you take an image, that's my son, /Emojify, you put the image in, there you go, it figures out the emotion, paste it back in. It works with multiple faces, multiple images, so you can put /Emojify, and there you go. And it has finally answered that age-old question that people have been asking for hundreds of years. What does a Mona Lisa smile? There you go. Answered it, you see? So, it does have a function. It is important. The question is, there's a lot going on with this application. A lot going on with this application, Excuse me. But I think one of the most interesting questions, when obviously I made it, so I'm surprised at myself, was how do you calculate emotion? Like, how do you actually calculate emotion of a face? I mean, as human beings, we find it tough to detect other people's emotion. Like, how do you teach a computer to detect emotion? And it's pretty easy. In fact, it's incredibly easy. There's only 2 steps. Just 2 steps, that's it. The first step is you need to actually detect the facial features. So now we know, after decades of research, what are the main facial features that most faces have? Maybe everybody's got 2 pupils, a nose, a mouth, the points on the mouth, the chin. These are kind of points that everybody has, and if you can you capture those points effectively on different faces? And there's various methods. There's pure algorithmic ones. There's ones that are actually a little bit more machine learning, and you can find out. You can just Google. There's a link there which has one method. But basically, you need to gather from an image. You need to gather the points of the facial features. And the second step is really easy. You just use a neural network. So just those 2 steps together, and then you can combine it into, and then that. Do you need to explain neural networks? Yeah, I'll take that pin drop as a yes. So I'll explain neural networks. And neural networks have a basis in biology. This is a neuron in your mind. You have at least one of these, hopefully. Has some dendrites going in, a body, excuse me, and an axon going out. If enough electricity flows in to the dendrites, the body fires, and electricity goes out to the axon. That's it. Simple. right? If you stick enough of these together, you get a brain. If I ask you to code this up yourself, you probably just go off. You're all presume JavaScript developers. If not, you're probably in the wrong lecture. But if you asked you to code this up yourself, you would go away and you'd probably try and do something like this. You'd create a node, some edges going into the node, something along those lines. And then maybe to represent, what is the electricity? The electricity is kind of some information that's going in. Maybe, every time I get to this slide, I forget what I meant that to be. Maybe that's temperature, that was it. Temperature, maybe one piece of electricity. Maybe this little neuron is going to decide whether you should wear sunglasses, okay? And a bit of electricity going in is a temperature today. Like, well, that's a temperature. Maybe another bit of electricity is the amount of sunlight. 0 being dark and 10 being pretty bright. And then you kind of give each of these edges some weights to determine kind of how important is that electricity. So the fact that it's the temperature high probably isn't that important. It's kind of 0.5. But the fact that it's quite sunny is probably quite important. You multiply it all together, sum it up, pass it through what's called an activation function, and whatever that pumps out, that's kind of your answer here. Maybe 1 means wear sunglasses and 0 means don't wear sunglasses. That's basically it. Excuse me. Just a multiplication and addition. All this magic stuff going on. It's just multiplication and addition in this case here anyway. There's lots of different types of activation functions. Might be the simple one we use here, where anything above 0 is 1, anything below 0 is 0. It's not a very good one. But that might be what your activation function is. But essentially, you get a load of these together, put them into layers, and you create a neural network. This is kind of a very simple 4-layer neural network. Excuse me, 1 input layer, 1 output layer, 2 hidden layers. And then what you get is, then you basically would initialize each of those edges with some weights to start off with, just randomly initialize those values. And then what you want to do is you want to basically start pumping in some data, some electricity, right? Maybe you've got a data set. There's actually a data set of images that have already been categorized with emotion. So somebody's actually gone through with like a set of images and said, that's a happy image, that's a sad image, that's a angry image. There's a data set of that already. You'd grab those. Remember, you get the facial features. Okay, you know what the facial features are. Maybe what you then do is you pump in the positions of those facial features as inputs. You just do that multiplication addition. You're doing that all the way through, and you're pumping out a number, right? What does that number mean? Maybe we want 0 to be unhappy and ooh, did you see that? 10 to be happy, right? But it's pumped out 3. Which is actually incorrect, right? Because we know that this image is 8. Because a human being has looked at this image and said, that's 8 happiness. So we know this neural network's wrong. We know it's wrong by 5. Once we know how wrong it is, we can then do something called, it's an algorithm called backpropagation. Essentially, this is the meat of what's going on. You know how wrong you are from the data because you know what the right answer is from the data. You figure out how wrong you are, then you tune those weights. Remember, you just initialize them randomly at the start. Of course it's going to be wrong, right? You tune those weights, and you tune them and tune them and tune them until eventually what happens is when you push that image of an 8 through, you get 8 at the end. That's the training process. That's what's going on with a neural network, right? That's what I could have used. Excuse me. And that's what I could have used. Could have quite comfortably used that, trained something like that up in this space to do the Mojify. It's all written in JavaScript. But with a lot of these kind of very, very common problems that there are in the world, and this is actually quite a common problem these days, kind of detecting emotion, almost all the cloud providers and a whole bunch of other people have started to commoditize a lot of this information to services. I work at Microsoft, we have one called the Face API. And that's basically what I ended up using. It does do something like this in the background. Obviously, it uses a neural network underneath. Even I don't know the specifics of it because that's proprietary. But it uses essentially a model like what I've described to you before. That's how it was trained. Pretty simple to use. You just basically post a path to an image or the binary data of an image to a URL, and it returns back to you a whole bunch of information. A whole bunch of information. Not just what I'm showing you here, but a whole bunch of other things as well. So for each face it detects in the image, it returns to you some data. It returns to you the position of the face, because, we need to replace it with an emoji. That's what we're doing here. And it also gives you some emotions. Anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise. 0 being none of that, 1 being a lot of that. Anybody have a beard? Beardies? Put your hand up. Okay. If you have a beard, you cannot be 100% happy. I've tried. I've only got to 99% happiness. That's the maximum happiness you can get. Not a bug. Anyway, I don't know. So yeah, there you go. So that's what I ended up using for the Mojify, essentially using an API like this, which gave me that same functionality behind the scenes. Just to summarize, just neural networks. I think incredibly powerful. That's where a lot of the growth in this area has been over the last kind of 5, 6, 7 years. But conceptually, they're quite simple to understand, right? I explained the absolute, I know this is the basics, absolute basics to you in about 5 minutes, right? Conceptually, they're quite easy to understand. That's it, first demo, first app, done, right? Gentle introduction. It's going to get more complicated. Next one, I'm fine. So I run a workshop sometimes, and where I teach kind of machine learning with JavaScript, and it's always wonderful. One of the best things you can do for a workshop instructor is then go away and build something based on the knowledge, and then send that link back to the instructor. Oh, this is what I built based on what you taught me. It's a beautiful feeling. So one of the guys in my workshop, Oliver Turner, went away and built an application, which I'm calling it I'm Fine. He didn't particularly name it in anything particular, but it's just this. It's basically, if you don't know what code pen is, it's just kind of like you can write JavaScript in the browser. It's a video. I'll show you how it works. So essentially what it's doing is it's doing a search for an image. It's getting the image, and then I don't know if you can see actually, in the bottom, excuse me, it's doing a detection of what's inside the image. So you can see here, it's searching for puppies, and 9.46% chance it's terrier, not bad. Searching I'm Fine, and it's returning that image, and it's saying it's a 70% chance it's a jersey, this is a fountain. So it's kind of okay, it's not doing a great job, but it's doing a job, right? But the most important thing about this example is that the only API request that's being made is to get the image. The whole detection of what's inside that image is happening in the browser in JavaScript. And it's using a technology called TensorFlow. Who here has heard of TensorFlow? Used TensorFlow? Okay, fair. 5% of the audience, I'll say. The TensorFlow is a technology. It was open sourced by Google in, I don't see the number here, I'm going to invent it. Oh no, 2015. And it allows you to do kind of computational mathematics across, parallelize them across your GPU, your graphics card, and also across multiple computers. Essentially allows you to do lots of mathematical number crunching, which is perfect for machine learning. But it's written in kind of, I think it's C++ or C or something. I don't know which it is, but it's basically a binary that you install on a server, or on a computer, right? So it's not so useful to us as JavaScript developers. And then like early last year, I remember, yeah, they released TensorFlow.js. Yeah. We love it whenever people add that .js after things, right? Gets us really excited. So when I first saw this, my first reaction was, okay, it's just kind of like bindings. Like you still have to install TensorFlow to use TensorFlow.js. But no, TensorFlow.js, when run in the browser, is a complete rewrite of TensorFlow from the ground up in JavaScript. Complete rewrite. Which has a very, very important impact. Which is this, is if you want to do machine learning with JavaScript, this is it. This is all you have to do. Just either, if you're doing kind of more modern JavaScript, you do an import for just TensorFlow.js, the JavaScript, or if you can even just drop a script tag in. That's it. That's all you need to do. And now you can start doing machine learning in the browser with JavaScript. And that's wonderful, because it helps people get started. It has other benefits as well, as you'll understand later, but that's all you need to do. Little caveat, if you're doing TensorFlow.js with Node.js, kind of server-side JavaScript, that is downloading the binary. That is downloading the full TensorFlow version, because you're running it on the server side. But if you're doing it in the browser, it's pure JavaScript. And you can do everything in TensorFlow.js that you can do in TensorFlow. You can train models, everything I showed you before with that neural network and the weights and the blah, 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 and the optimization. You can do that with TensorFlow.js, pretty simply. But you can also load pre-trained models. You can load pre-trained models. So these are kind of models that are available. Someone maybe computed them on like thousands of servers for weeks, created them. You can export them as JSON in kind of slightly different format and make them available on the internet. Then other people can use them easily from your browser. And that's all you need. That's all you need, that one line at the bottom, tf.load model, pass in the path to a JSON file. Boom. You can then use that machine learning model. You can't, that's not, you're not training it there. You're using a pre-trained model. If you go to the TensorFlow.org/JS website, you'll find a whole bunch of pre-trained models that you can start using with instructions on that site there. And what Oliver ended up using was one called MobileNet, okay, which basically is an image recognition model. It's mobile, so it's small, it's like optimized to be work on a mobile, and it's small, just about reasonably small enough so you can load it over the internet in a browser. It's still pretty large, to be honest with you, but you can load it up in the browser. And that's it. Just basically four lines of code, 1, 2, 3, 4, and that's all you need. You get the image from the screen. You load MobileNet, which is then going to load the actual load model, and then you just pass the image to model.classify, and then it gives you the predictions back. Underneath that, there's this is kind of a wrapper to TensorFlow, so there are like a lot of other things that's going on underneath there, but they've just given you in 4 lines of code, right? That's it. To do that functionality. I think that's pretty incredible. Like 4 lines of code to do machine learning, to detect what's in an image in the browser locally without making an API request. That's pretty cool, right? But as you saw, it wasn't doing like actually a great job, right? Because the MobileNet can only actually detect kind of 1,000 things in the world. That's it. That's why it's so small and optimized. It can only detect 1,000 things in the world. If you really want to have something that can detect a load more, you need a much bigger model. So you either need to train something yourself, or can anybody guess what I'm going to say next? Close. You can use one we made. So there's another API that we have at Microsoft called Computer Vision. Similar story. You pass in a path to an image, and it tells you what's inside the image in excruciating detail. So much detail. It's shocking. Not shocking. It's brilliant. It's fantastic. But one of the things that it does a lot of things, but one of the things that it does that I just really kind of narrowed down on because I just thought it was so incredible is it can give you a human-readable description of the image. A human-readable description of the image. One of my friends, Sarah Drasner, went away and thought, well, you know what, that's actually quite useful for the web because what we're supposed to do every time we add an image tag to a page is we're supposed to add an alt property which has the human-readable description of the image. So if you're for accessibility reasons, if you're using a screen reader and you can't see, it will read out the description of the image. It's something we're supposed to do, but a lot of web developers forget. So she was like, well, wouldn't it be great if you just had a tool which then basically did it all for you. So did a little demo. Again, it's in CodePen, and you can basically give it an image. Does anybody know this TV show? Anybody know it? Just like two hands. Come on, this is *Halt and Catch Fire*, right? It's a fantastic TV show. It's about the birth of kind of computing in the internet. Well, modern computing in the internet. It starts in 1985 to kind of 1993. Absolutely fantastic. I've never watched the last episode ever. I will never watch the last episode. This will never end for me, right? Absolutely love it. But anyway, you can pass it an image. So if you can see there, what it returns is Mackenzie Davies et al. Standing in front of a building. So Mackenzie Davies she's one of the characters. The actress is Mackenzie Davies there. So it didn't just say like 3 people or whatever. It like knew it was Mackenzie Davies and a bunch of other people. It knew it was her. And kind of standing in front of a building is kind of what they're doing, right? Pretty accurate, I think. Pretty good. Hell of a lot better than Terrier 9.96%, right? But Sarah released this on Twitter, and as we know, Twitter is full of very, very helpful people who tell you when you're wrong and when things don't work. And so they very helpfully told her of several times when it doesn't work. So this is one of them. So it came back with a star-filled sky. Text says 4, something. Okay. The next one could be true. The next one could be true. Like you don't know. Like you don't know. That could be a whole bunch of dead cats on a cushion. You have no idea. The next one, I'm pretty good with. Next one, we got 50% correct. 50% correct. Hand up on the camera. Okay, so not perfect, but still pretty good. Still pretty good. Still pretty good. So just to summarize. All right. If you're going to take one thing away from this talk, just take this sentence, is that TensorFlow.js doesn't have any dependencies. You don't have to install TensorFlow to use TensorFlow.js in the browser. It's rewritten completely from the ground up in JavaScript. MobileNet is like, whenever I do my workshops, I always start people off for just using MobileNet. It's a very, very, very nice, gentle introduction into this whole space. But as you saw, it doesn't really do a great job of that kind of stuff. So if you are really wanting to do, or you've got some ideas for something you want to build, which does some deep image analysis, you're best off using an API. And obviously the Azure Computer Vision API is the best one of all of them. All right. That was the second demo. How are we doing for time? Good, right? Yeah. Last demo. It's my favorite demo. I love this demo. It's a good one. All right. Image to image. You can find, again, you can find all of these on AI.js Rocks, and some of them have like even articles that explain a lot of this stuff. And this is one of the ones which has a large article written by the author where he goes into great depth regarding the algorithm and everything that he's used to build it. And the best thing, I'm just going to show it you. I'm just going to show it you, right? This is it. This is running in the browser. So basically, if you draw the outline of a cat, it will draw the rest of the cat. Right? That's what it's doing. Built by a gentleman called Zaid. He's in Saudi Arabia, still at university. What was I doing at university? I wasn't doing this. I don't think he'll have a problem getting a job afterwards. So how it works is it uses an algorithm underneath called Pix2Pix, which is essentially using an algorithm, excuse me, called a generative adversarial neural network. Okay, generative adversarial neural network. I'm so sorry, I'm going to cough again. Okay, this is how one of those works. And now you understand You understand all of this now, so it's going to be quite easy for you to grasp what's going on. So it uses two neural networks, that are competing with each other. Okay, you have a generator and a discriminator. A generator and a discriminator. The generator's job is it takes as input something like maybe you've got a data set of outlines of cats, okay, and its job, if you feed in an outline of a cat, it's going to generate an image of a cat. But remember, when you initialize these neural networks, they're just randomized to start off with, so it's not going to do a very good job of generating a cat image at the start. But doesn't matter, you don't care. You take all those generated images it generates, and you combine it with real cat images, a real data set of real cat images, you mix it all together, and you pump that through the discriminator, and the discriminator's job, its only job, is to detect whether an image is of a real cat or a fake cat, right? That's its job. If it got it wrong, and of course it's going to get it wrong because the discriminator itself has been initialized with random numbers, then we optimize, we tune those weights, the discriminator gets better. Oh, tickly cough. But, if the discriminator, even if the discriminator gets it right, well, that means the generator's not doing a very good job of generating cat images. So you figure out how wrong the generator is, and then you choose that in the backpropagation algorithm to tune the numbers in the generator, and the generator gets better. And then what happens is as the generator gets better at generating cats, the discriminator gets better at distinguishing a fake cat, and they compete with each other, and they each improve and compete, and each improve and compete, and they get better and get better and get better and get better, until eventually the generator is doing such a good job of generating cat images that the discriminator just can't tell anymore, right? Just can't tell anymore, and then you kind of stop. You're like, fine. Well, we don't care about the discriminator anymore. We just care about the generator. And you export that model. Now you export that model as what we described before. What I just showed you here probably isn't realistically possible in the browser with JavaScript. You'd do this somewhere else. But you can export that model and optimize it and tune it a little bit so it can be used in the browser. And then in the browser, once you give it an image, it'll generate you an image of a cat. Right? That's how it works. That's image to image. Pretty cool, right? Yeah. But so what? You can generate images of cats. Who cares? Like, is that important? Is it as valuable a tool as the Emojifier? I don't think so. But it doesn't just have to work with cats. You can train it to do anything you want. All right. Here's the similar one. It's like outlines of people and generates images of people, right? This isn't image to image or pics to pics, though. This is vid to vid. It's a different algorithm. This isn't possible in the browser yet, or JavaScript yet. But there's a link there. You can find details about it. And again, those are generated images. Those not real images. How about this one? One input, multiple outputs. That's interesting. The input doesn't have to be outlines of things. The input can literally be anything that you want it to be. Here's an input, which is a segmented image, and the input is the colorful image on the left. And the different colors kind of give some information about depth and other information about the image. Then you can do things like this. So she's not dancing. There's a generated images. Right? Here's another one. This is a car scene. The diagonal ones are some other algorithm. That's the vid to vid in the bottom right-hand corner. And the input image is a segmented image, which kind of gives you information about kind of what's in the scene. And that's a generated image in the bottom right-hand corner. There you go. But as I said, the input doesn't just have to be, input could be anything, anything at all, anything in the slightest. You can train these things up to work with anything. You can train it up to work with text. So this is one that, this is one. In fact, the Microsoft team had like a really lovely website where I could show this demoing in real life, but live, but it's not working today. Not related to the outage. So those the inputs are at the top. So this flower has long, thin yellow petals and a lot of yellow anthers in the center. That's the input. The text is the input. The image is the generated output. Stage 1 is after 600 epochs. Epochs. And stage 2 is after 1200. Pretty cool, right? Yeah, that one's not so good. But the rest are very good, I think. And there's one working with birds. So this bird is white, black, and brown in color with a brown beak. My thingy's not working. But you can see at the bottom birds, apart from one at the end, one or two at the end maybe, they're very good. These are generated images. That's what's so exciting about a GAN. They generate things. Like lots of other kind of machine learning things that we do, they're very discriminatory. They're like, oh, is this a water bottle or a clicker? They discriminate things. Generative neural networks generate things. They're beautiful. Like they're creative. Like they create. And that's so interesting about them. How far away do you think we are from somebody just typing into a page, need an e-commerce platform, maybe use this as a reference architecture, I need a website, my main theme should be blue, I like birds, go. Right? There's a wall on the outside where you do the thing where you tie your a little piece of string. Have you seen that? And you say like when was the first, how it's your first time here, and this and this and this, and the last one is when will AI take over your job? So maybe it was a joke. Maybe not so funny, right? Maybe it's actually more serious. I do give this talk. I've given it a few times before, and I gave it once at a I want to say a large company that makes websites, and the CTO at the back shouted, "We're looking into that." So maybe not so far away as you think. So just to summarize, GANs learn to generate new images, new things. They're kind of generative. That's kind of you see a lot of them in kind of used in very creative ways, artistic ways, musical ways. They take a lot of compute to train, like a lot more than the typical, like some of the other stuff I showed you. They take a lot of compute to train, but the generated model can be exported and be run in the browser, and that kind of be quite interesting. You'll see there's a lot of people doing some maybe not so practical, with a business use case or something. There's a lot of artistic stuff happening with GANs. It's very, very, very interesting to see. If you're interested in TensorFlow.js, a little plug for a book I am writing. It's called, what's it called? Introduction to Machine Learning with TensorFlow.js. If you want to know when it gets released or something, just take a picture of that. And somebody took some pictures, excellent. And I'll let you know. If you want to learn a little bit more, maybe about from the earlier stages, I wrote a whole tutorial on how to build Emojifier. And if you want to learn how to do like a Slack bot, I'll teach you everything from doing the APIs and doing everything all the way to creating a Slack bot step by step all the way through. And that's it. Thank you very much for your time. Cheers.